Hey everyone, how's it going? Sorry about this late video. I did it on my iPad because it's graphing and I didn't want to have to erase my graph all the time. But when I went to go find it, couldn't find it, so now I have to redo it. So I'm sorry for the lateness. It won't happen again. Probably said that last time, huh? That's my bad. Anyways, we're doing graphing trig functions. I might go through this a little bit quicker, so you just need to pause the video because I'm doing this during a prep period and I don't have as much time. So we're graphing sine and cosine this year, no tangent. We'll do the parent function here. Remember, parent function is where where all the other functions of the same type come from. So here's our graph. We're going to go from 2 pi to negative 2 pi. Now, just for sake of time, I'm going to show you. No, we're not going to do that. Sorry. Here's pi. This is pi over 2. This is 3 pi over 2. We're going to graph the unit circle here. All right. So now, remember that with trig functions, you plug in an angle, and what you get out is a numeric value. Okay, so you plug in an angle, and you get a numeric value out. So let's just start. Sine of 0. If I plug in 0 radians here, sine of 0 is 0. So there's my point. Let's do pi over 6. Pi over 6 is about right here. So sine of pi over 6 is 1/2. Right there. Sine of pi over 4, square root of 2 over 2, which is about right there. It's 0.707. Just put it in your calculator. Sine of pi over 3 is square root of 3 over 3, so about right there, or 0.86. Sine of pi over 4, or excuse me, pi over 2 is 1. And then we're coming back down, right? Sine of 2 pi over 3, square root of 3 over 3. Sine of 3 pi over 4, square root of 2 over 2. This should be over a little bit. Sine of 5 pi over 6 is 1/2. Sine of pi is 0. Okay, sine of 7 pi over 6 is 1/2. And we'll just skip to sine of 3 pi over 2 is 1. And then sine of 2 pi is 0. Right, and sine of 11 pi over 6 is 1/2. So if we draw our curve here, not perfect, and it's never going to be perfect, sorry. That's kind of the shape of our graph. Wow, that is horrible. This is supposed to be more over here. Sorry, that was really bugging me. There we go, that looks a little better. Okay, now this side keeps going up. Okay, we just graphed, what we did was we used a unit circle to graph our sine function. The unit circle, you just keep going around in circles, you get the same value, right? The values never change. So the graph just keeps repeating itself. Even the negative values. Negative 3 pi over 2. Because we're going the opposite way around the circle, clockwise, the values didn't change. We're just going the other direction. So it just repeats itself. So down here, 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 here. Right, it keeps repeating itself. This is called a wave. Okay, the shape of the graph is a wave. But this is the generic shape of the sine function. Right, the reason that it repeats itself is because we just keep going around the circle. Now, we're going to be looking at a specific part. We're only going to be graphing this year, and all years, really, from 0 to 2 pi, because that's our unit circle. Okay, so we're not going to worry about all the parts of the graph. We only care about 0 to 2 pi because everything else is just a repeat of that. So we only need to graph one part because everything else is just a repeat. Let's look at cosine. So y equals cosine of x. So you got 2 pi. It's going to go up to 1. It's going to go down to -1. Here's negative 2 pi, negative pi, negative 3 pi over 2, negative pi over 2, pi, pi over 2, 3 pi over 2. Now, from here on out, how we're going to graph is we only need to graph 5 points. We're going to take the 5 points from the parent function. That's what we're going to move around when we do our transformations. Y-intercept, x-intercepts, maximum, minimum. To find that out, you take your 2 pi. This is actually the period, and we'll talk about the period is in a second. You take your 2 pi, or the period, divide it by 4. You cut it into fourths. So that's pi over 2. So you take this length, cut it into fourths, and so every increment is pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 2 pi, or 2 pi, or 4 pi over 2. Right, and then you draw your graph. So cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. And that kind of gives you your generic shape of the graph. Okay, that's all we're graphing. You only need those points. You have to do all of them. That gives you your generic shape. Over here, similarly, this would be 0, negative 1, 0, positive 1. Like that. And once again, this graph goes on for forever because it's just a repeat of the unit circle. And once again, we're only looking from 0 to 2 pi this year when graphing, and all years, because it just repeats itself. 0 to 2 pi is the unit circle. Because we keep going around the circle, it's repeating itself, so we only need to look at from 0 to 2 pi, because then we know what everything else looks like. Now, notice, this looks very similar to the sine graph. In fact, the sine graph is like this. It looks really similar. It just looks like it's been shifted over, huh? It's because it has been shifted over. If you look at your unit circle, right here at 0, right, 0 radians, and right here at pi over 2 radians, sorry, this is backwards, 1 comma 0, 0 comma 1. The sine of 0 is equal to 0, right? It's the y value. The sine of pi over 2 is equal to 1. It's the y value, or excuse me, cosine. My goodness. Sorry, this is what happens when you try to go a little faster. The cosine of pi over 2 is also 0. It's the x value. They're the same values. They've just been shifted pi over 2. It's the same with the graph here because it comes from the unit circle. Cosine and sine are the same exact shape. It's just been shifted. Okay. Let's do some definitions. So we're going to talk about amplitude. And I'm going to use the sine graph. Now, I'm only graphing from 0 to 2 pi, so this is what I'm going to show as my graph now. So right here. We're just looking at from 0 to pi over 2. So there's my graph. Amplitude. Amplitude is half the distance from the maximum value to the minimum value. Right, so the minimum value here is 1. The maximum is, or excuse me, negative 1. The maximum is positive 1. So from negative 1 to 1 is 1, 2 units. Half of it divided by 2, the amplitude is 1. Okay, another way you can look at it is this halfway line here kind of cuts the graph in half. You can see kind of cuts it equally in half. The distance from the halfway line to the maximum is 1, or the distance from the halfway line the minimum is 1. That's also your amplitude. Okay, another way of seeing it. Oh, no, I'm going to show you that in a second. Let's talk about a cycle. A cycle is the shortest distance for a repeated pattern. So our shortest distance for a repeated pattern is just the unit circle, right? So our cycle is from here to here, right? Because after that, it just starts to repeat, right? And before this, it starts to repeat. So our cycle is from here to here. This shape of the graph right here is your cycle. The period is the numeric value of the cycle. So here, the shortest distance of my repeated pattern is 2 pi. Right? Because we go around the circle once, and then it repeats itself, and around the circle once is 2 pi. So my period, the shortest repeated pattern distance, is 2 pi. In fact, the period for sine and cosine is 2 pi. And we're only going to be graphing one period in this class, so from 0 to 2 pi. Let's talk about something called a phase shift, because that's a new definition. So a phase shift is just a horizontal shift. But we call it a phase shift because it deals with we're dealing with waves now. So let's see, we have kind of like this. Okay, if I do a phase shift, it's a horizontal shift. So I could move all of my points over and kind of be like that. Notice it's the exact same shape of the graph, but I've moved the graph over. I can also move it right. So notice that cosine and sine are phase shifts of each other. Right, pi over 2. That's what a phase shift is. Oh, sorry, I didn't write the definition down. It's a horizontal shift. Okay, a couple more things here. How to find the amplitude and the period of your function. What I'm going to do, I'm going to write down our generic function for sine and cosine. So it's y equals, or f of x equals, a times the sine of b times x minus h plus k. All right, so here the a is the amplitude. Okay, a is the amplitude. You find it by taking the absolute value of a. B is the period change. You find the period, if there is a period change, you find the period by taking the original period, so 2 pi in our case, and divide it by absolute value of b. H is the phase shift. Okay, and it's opposite sign. So for example, if I had plus pi over 2 as my phase shift, I would go minus pi over 2 when I'm actually graphing it. And then K is the vertical shift. This is nothing new to you, the vertical shift. It is same sign. So vertical shift, it just moves up and down. In fact, something I like to tell my students that helps them remember all these is if it's inside, so if it's inside the function, it's opposite operation. If it's outside the function, it's same operation. So let's just using this stuff, these definitions here, Hopefully you have this written down, so pause the video if you need to. But we're gonna graph these four, practice these four. Oh man. I thought I didn't start the video. I got freaked out because, like I said, I just spent, well, this one I'm going through a little bit quicker. The other one I didn't. I was kind of more chit-chatty, like using them. But it was like maybe 35 minutes long. And I spent it. I pushed record, and it was recording. And then what happened was it's the family iPad, or I guess taking my wife's iPad. So she's logged into it with her Apple ID, her Apple account. And so anything that happens on her phone also happens to the iPad. So what I didn't realize is that it stopped recording because something happened on her phone. I think she got a call or something like that. I didn't know it stopped recording. So I'm recording, and I go to turn off recording, and it's not there. Like it says it's not recording. So I go to try to find it because I know it was recording. I saw it went 3, 2, 1, and then turned red and said recording, and it's nowhere to be found. Even half of it is nowhere to be found because I could splice the videos together. But so that's why we're doing this. Anyways, I got freaked out because I was like, this is not happening again. Anyways, so we have f of x equals 4 sine of x. Okay. So remember, our generic function is that one. So here, the only thing that's changed is our 4 here. So how we're going to graph this in class, because I don't want you to forget things, any transformations, because there's a lot. There's 1, 2, 3, 4, and if a is negative, then there's 5 because of the reflection. So there's potentially 5 different transformations, and they all kind of depend on each other. So I'm going to show you a method of just doing one transformation at a time, and then you never forget anything. Now it's going to be a little long and tedious, but you'll never forget anything. And if you feel comfortable later on, then you can skip some of those steps. But for now, I'm going to show you the whole process. So we're going to start by graphing the parent function for sine. So we're going to graph sine of x. So our period is 2 pi, right? We've already established that. Now, like I said, you take the period, you cut it into fourths, and that's all you need to graph. So if I take 2 pi, cut it into fourths, it's pi over 2. So I'm going to go in increments of pi over 2. So I start at 0, pi over 2, 2 pi over 2, or 2 pi over 2, which is just pi, 3 pi over 2. Okay, sine at 0 starts at 0, and it goes up to 1, down to 0, down to negative 1, back up to 0. Okay, there's your parent function. Now, I'm going to take the parent function, and I'm going to do the amplitude transformation. So the only thing that's changing is the amplitude, the distance from the midline to the max or the min, right, or the distance from the max to the min. That's the only thing that's changing. Nothing else is changing. No points are changing. No angles are changing. Just how tall the graph gets. Well, our amplitude is this number right here, right? A is equal to 4. Or absolute value of 4, which is just 4. So my amplitude is 4. So instead of being 1, now it's 4. Instead of being negative 1, now it's negative 4. Another way you can look at this is you're multiplying everything by 4, right? And it's outside the function, so it's with the y values. Okay, I don't know if your SM2 teacher showed you that. They should have. Well, I guess I don't know. I guess I'll review that real quick. Anything inside the function affects the x values, or the left and right. Anything outside the function affects the y values, or up and down, or the output. So here it's outside the function. It's affecting the output, the y values, and it's multiplying by 4. Remember, outside the function, same operation. So if I take all my y values, for example, 1, multiply it by 4, I get 4. 0 multiplied by 4 is still 0. Negative 1 multiplied by 4 is negative 4. So all that's changed is, oops, I just drew the cosine function. There we go. All that's changed is how tall the graph is, 4 to negative 4. And this is your answer. This is your graph. Right, this is 4 sine of x. Let's do another one. Maybe I'll start doing, I'll do different colors for these next ones, so you can kind of see the progression. F of x is equal to cosine of 2x. So I'm going to do the parent function first. So cosine of 0 is 1, down to 0, down to negative 1, up to 0, up to 1. Okay, there's my parent function. That graph is cosine of x. Okay, now we're going to graph cosine of 2x. The amplitude is still 1, right? There's no number in front. The amplitude is still 1, so that doesn't change. But now we have cosine of 2x. Remember our generic equation, a times cosine of b times x minus h plus k. Right? The b in front, the multiplier, is our period change. So how to change the period? We take our period, 2 pi, divide it by absolute value of b. So 2 pi divided by absolute value of 2, which is 2. My new period is pi. So new period is pi. Once again, to find the points you need to graph, you take your period, so pi, divide it by 4, right, cut it into fourths, and those are the points you need to graph. So we have pi over 4, 2 pi over 4, which is pi over 2, and 3 pi over 4. Okay, that's what you need to graph. Yeah, you can see that. Okay, now the angles changed, but the points didn't change, right? The y values. So we're still here at 1, 0, negative 1, 0, 1. And there's your graph. Cosine of 2x. That's your graph. Okay. Now this kind of makes sense that our period would be pi. So a period is saying that this repeats itself every pi instead of 2 pi. Well, that makes sense because what we did was we took our angle and multiplied it by 2. So it should repeat itself 2 times faster, right? Because the angles are twice as big now. So it goes around the circle twice as fast. So our period is pi, and this is your answer. This is what I'm looking for. I know it's basically the same as this, but what I'm looking for is that you understood that the period is now pi, right? And thus the angles, right? What you got, the angles cut themselves in half almost, right? So we took our pi, our period divided by 4, and those are our new graphed points. So this is what I'm looking for when I'm grading. Do you have your points here labeled correctly? Okay, that's what I'm looking for, because that tells me that you know the period. Let's do the next one. This one we're going to put a couple things together. Let's see if I can go. There's my blue marker. So we're going to do f of x equals 2 times the sine of 4x plus 3. So parent function first. 1, negative 1, 2 pi. Pi over 2, 3 pi over 2. And it's sine, so we start at 0, go to 1, down to 0, down to -1 to 0. So there's sine of x. Okay, now we're going to do the amplitude next. That's still, yeah, there it goes. Yeah. We're going to do the amplitude next. Our amplitude is 2. So we multiply our y values by 2. So 2 times 1 is 2. 2 times -1 is -2. But our angles have not changed. So we have 2 pi, we have pi, 3 pi over 2, pi over 2, 0, 2, 0, -2, 0. So this graph right here is 2 sine of x. Okay, so we did the period. Now, the amplitude. Now we're going to do the period change. So now we're going to graph 2 sine of 4x. So our amplitude is the same, right? It's 2 to -2. But our period is different now. We take our original 2 pi, divide it by absolute value of b, or 4. So my period, 2 pi over 4, is now pi over 2. So my period is pi over 2 now. I take my period, pi over 2, divide it by 4, pi over 2. Those are the increments that I'm going to graph in. So cut it into fourths. So I have pi over 8, pi over 4, which is 2 pi over 8, and then 3 pi over 8. Okay, so my x values, or my angle values changed, but the points don't change location, so it's still 0, 2, 0, -2, 0. There's that graph. I've got one more. I'm going to go back to black because I don't think red shows up very good on the video. So now we're going to do our +3. Remember, it's outside. +3 is our k. It's our vertical shift. And it's same operation because it's outside the function. So we're going to take all of our points here and move them up 3. So if I do that, my graph is going to look a little different though. So I have pi over 2, pi over 4, pi over 8, and this is 3 pi over 8. Okay, so I started at 0, I was at 0, but I added 3, so I need to go up 3. So 1, 2, 3. There's my new point right there. At pi over 8, I was at 2, but I need to go up 3. So 1, 2, 3. Now I'm at 5. At pi over 4, I was at 0, but I need to go up 3. So now I'm at 3. At 3 pi over 8, I was at -2. I need to go +3. -2 plus 3 is at 1. So right there. At pi over 2, I was at 0. I need to go +3, so I go up 3, back to +3. Woo. And there's my new graph. So notice these graphs are the same. I shifted it up 3. This is your ending answer. This is the correct answer. Okay, it shows me your vertical shift. Sorry, this is 5, and this is 1. Shows me your vertical shift. Shows me your period change here with your angles. It shows me the amplitude by labeling the 5 and the 1 here. Okay. All right, let's do the last one here. Making decent time. So here we have f of x equals -3 cosine of 2x plus pi. We're going to get this in the format, in our generic format. So we have f of x equals -3 cosine. Now our generic format has x with a coefficient of 1. So I need to factor out a 2 here. So I'm going to bring out the 2, and then I have x, And I factored out 2 from pi, so it's pi over 2. Okay, so here our amplitude, A is 3, right, absolute value of 3. Now the negative means we're going to do a reflection. I'll show you that. B here is positive 2, and then H is negative pi over 2, right, opposite operation inside. So we have 4 steps here. Let's do the parent function, so -1, 1, and we got 2 pi, this is pi, 3 pi over 2, pi over 2. It's cosine, so we start at 1, 0, -1, 0, 1. Okay, this is cosine of x. That's our parent function. Computer keeps shutting off. I keep thinking it's going to stop recording. Okay, now let's do the amplitude. So we're going to do 3 cosine of x, not with the negative, just the 3. So our amplitude, right, multiply everything by 3, our y values, so 1 becomes 3, -1 becomes -3. The period did not change, just the amplitude. So we're still at 3 now, 0, -3, 0, +3. Okay, now we're going to do the -3. So -3 cosine of x. So once again, our amplitude is not different. We still have 3 to -3. Our period is not different, so we still have the 2 pi. Okay, but this negative changes all my y values and changes the sign, right? Multiplies it by a negative. So here at 0, I was +3, so now I'm at -3. Here I was at 0, so now I'm at -0, which is the same. Here I was at -3, change the sign to +3. Here I was at 0, change the sign to -0, which is the same. And then here I was at 3, change the sign, -3. Okay, so there's my new graph. Notice it's just a reflection of itself. See, I just flipped it. Now let's do the period change. So now we have -3 cosine of 2x is what we're going to graph. So we're at 3, -3. Now my new period, I take the original period, so 2 pi, divide it by b, which is 2, right, or absolute value of b. So my new period is pi. Cut pi into fourths, so increments of pi over 4. Okay, and now these points stay the same. So we're still down at -3, 0, +3, 0, -3. Like that. And we got one more to do, our phase shift. Let's see if I'm going to have room. Okay, what I'm going to do is I'm going to erase the parent function here. If you need it again, just rewind the video. So I'm going to take this. This is now going up in here, and we're going to graph the -3 cosine of 2x plus pi. We're doing our phase shift now. So we're going to need some negative points, though. 3, -3. All right, so phase shift is positive pi over 2. Now that's what's inside, so we're going to do the opposite operation, so we're going to go negative pi over 2. So we're shifting everything to the left, pi over 2. Well, here at 0, I start at 0, so 0 minus pi over 2 is negative pi over 2. I'm down at -3. So I took this point, shifted over pi over 2. Pi over 4 shifted over pi over 2. So I take pi over 4 and shift it to the left pi over 2. I get negative pi over 4. So So negative pi over 4, and that's at 0. Right? It was at 0 originally. Pi over 2. If I shift it to the left pi over 2, I'm at 0. So now I'm at 0, comma 3, right? Because it was at 3. The y value is 3. So it's still at 3. 3 pi over 4. If I shift 3 pi over 4 to the left, pi over 2, I'm at pi over 4. So right here. And it's 0. It's at 0. The y value. And if I'm at pi, and I shift it pi over 2, now I'm at positive pi over 2, right? Pi minus pi over 2 is pi over 2. And it's at negative 3. And there's your graph. So notice, between this graph and this graph, this one's all positive values, but we shifted everything to the left, so now we have some negative angles. And this is your answer. This is what I'm looking for. It has your period. I know what your period is. It's pi, because it's from negative pi over 2 to pi over 2. I know your horizontal shift because you had to come over the negatives. I know your amplitude because you have it labeled here. Okay. And I know that it's a reflection because the shape of the original cosine would be the flip, right? Not the inverse, but just it would be flipped. Now, we're going to do more practice of this. Don't worry. This is just introduction stuff. But this is a little harder. There's more definitions to remember. There's certain steps you have to do in a certain pattern. So you need to practice this. You're going to have to practice or you're going to fail. I'm sorry. Because it is harder. But that's it for the video. Once again, I'm here every day after school. So come talk to me if you need help.